Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 1 and 2 class. Today we are going to start a very awesome part of Algebra 2, and it's called conic sections. Okay, conic sections sound really crazy, but they're actually not that bad at all. We're gonna work on all of them, and you're gonna see how you're gonna become masters of this. Now, in this chapter, like I said, we will be studying conic sections, and there are 4 conic sections, which include circles, which is what we're going to do today. Those are the easiest of them all. Parabolas. Now, you're thinking, wait a second. Didn't we already graph parabolas using a table? And then we graph parabolas using the vertex form. We wrote the quadratic function from standard form to vertex form. Didn't we do it already? Yes, but there's one more fabulous way to work with parabolas. You have ellipses. Ellipses, that's a lot of orbital movement on Earth is in space is elliptical. And then you have hyperbolas, okay? So these are the 4 conic sections or graphs or functions that we're going to learn how to graph in this chapter. These are known as conic sections, just so you understand, because they originate from or are formed by different cross sections of right circular cones. A cross section is when you get a flat surface or plane and you literally cut something in half, kind of like when the magicians stick a board through a box and someone's body is supposed to be in that box. That's a cross section. So these yellow planes are the cross sections. And if you take a vertical cross section of a cone, you're going to have a circle. If you take a vertical cross section of a cone, you're going to have what's called an ellipse. Okay? If you take a slanted cross section of a cone, you're going to be left with a parabola. And if you take a vertical cross section of both cones that are on top of each other, that are reflected over the x-axis, you're going to have, it looks like 2 parabolas, but those are really a hyperbola. Okay? So those are the 4 conic sections that you guys are going to learn about and graph. Not that bad, to be honest with you. Okay, number 1, the circle, midpoint and distance formulas. Let's talk about some nuts and bolts before we get ready to graph this, okay? A circle is any set of points that are equidistant from the center point of the circle. That equidistance is called the radius, guys. From the center to any point on the circle, bless you, and I mean any point on the circle, these are all equal. That's the way a circle works. Okay? The radius, or the radii, plural, of a circle is always equal within that circle. They're always congruent. So when you have a figure that is equidistant, the perimeter is equidistant to the center, that is called a circle. Okay? The radius is that segment that is equidistant from the center of the circle to any point on the circle itself. Okay? Always. All radii of the same circle have equal lengths. Now the diameter was this guy. The diameter goes through the center of the circle and it hits 2 endpoints of the circle as well. Okay? And the diameter is a segment that goes from one point of the circle to another point of the circle through the center of the circle. The diameter is 2 times the radius, and the radius is the diameter divided by 2. Everyone with me so far? Pretty easy, right? This all should be kind of review. You've seen this before. Now, excuse me, sometimes you have to find a midpoint and or a distance of the segments in order to find the radius or diameter of a circle using the following formulas. Luckily, we've already seen these formulas. It's the midpoint formula. If you remember the midpoint formula, it's the average of the x values, comma, the average of the y values. So it's x1 plus x2 divided by 2, comma, because the midpoint is a point, it's an ordered pair, y1 plus y2 divided by 2. That will give me the midpoint of a segment. How would that be useful? Let's say they give you a circle, and they give you your x1, y1 here, and they give you your x2, y2 here. Okay? If I want to find where the radius is, wouldn't the radius be the midpoint of that segment? Okay. The center will be the midpoint. And then you can find the radius from the distance formula from here to there. So the midpoint can help locate where the center is. Once you have where the center is, you may need to find the distance. Or you could find the distance of the diameter and then divide it by 2. Or you could find the center and then find the distance from the center to the point on the circle. Distance d equals x2 minus x1 squared plus y2 minus y1 squared. And this gives you a distance. Okay? Everyone with me so far? Easy formulas, right? Okay. Let's get to the fun part. When we're looking at a circle, okay, I want you to realize that you're going to have a center. This center is HK. We have seen H and K before, haven't we? Right? H affects the graph by shifting it left or right. It's an opposite motion. If it's x minus 2, you go to the right 2. If it's x plus 2, you go to the left 2. And then the K, brings up the function either up or down, depending on if it's positive or negative, right? Okay. The HK affects the circle the same, except it's affecting the center. Okay? And the radius, of course, the radius is the distance from the center to any point on the circle XY. That's what's happening with the circle. What is the formula that is driving this circle? Well, it's very simple. The standard form of an equation of a circle with center HK and radius R is x minus h squared plus y minus k squared equals r squared. Why is the h attached with the x? Because x is a left or right, right? It's a horizontal. Why is the k attached with the y? Because it is a vertical. It is an up and down. You with me there, guys? Okay. So, how does this work? Graphing a circle is the easiest thing in the world, man. Find and graph the center of the circle, HK. Find it, okay? And graph it. Find the radius and move that many units up, down, left, and right from the center of the circle. Connect the dots, and you're done. Literally. A, what's my HK here? In this case. 0, 0. Very good. What's being added to the x, guys? What's the h there? 0. What's being added to the y? So that's the k. So 0, 0. My r squared is 16, so what's my radius? 4. Because isn't r squared 16, right, guys? How do you undo a square of 2? Square root it. Okay. So I've got up 1, 2, 3, 4. To the right, 1, 2, 3, 4. Down, 1, 2, 3, 4. To the left, 1, 2, 3, 4. And I'm not that great of an artist, but that would be my circle. If you had a compass, you would do it exactly perfectly if you put your compass point right on the center and just follow the 4 points that I created. That's it. That is a circle. Pretty simple, right? Okay. Number 2, x plus 2 squared plus y minus 3 squared equals 25. Okay, what's my HK? Negative 2 and positive 3. If you remember, if you notice rather, in this case they're both minus, right? So when my h is negative, it looks like a plus here. But when my h is positive, it's minus. When my k is negative, that's a plus. But when my k is positive, it's a minus. Okay? So it's always opposite. 2 is positive here. So what's the h really? The h is negative 2. This is negative 3. So what is the k for real? Positive 3. It's x minus h, y minus k squared. If I have x plus 2, h is negative 2. H is always the opposite in everything that we have seen so far, because you had something like this. The k was outside. So the k was legitimate, outside. But this time, is the k by itself or is the k encapsulated with the y? It's encapsulated with the y. So the same opposite effect you have on h, you have on k in circles. Great question. Great question. Thank you. What's my radius here, gentlemen? 5. So my center is negative 2, 3. 1, 2, 1, 2, 3. So I'm going to go up 5, down 5, left 5, right 5, because that's my radius. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And bada boom. Done. That's my circle. Does that make sense, boys? Easy, right? Okay. How about here? What's my h? What's my k? What's my hk? What's my center? 5, 3. What's my radius? So 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3 to the right. 1, 2, 3 up. 1, 2, 3 to the left. 1, 2, 3 down. Circle, circle, circle. Boom. Done. Circle is graphed. Does that make sense? Okay. That's the easy part. Right now we have another part. It's not that bad either. It's pretty easy. May I continue though? Okay? You guys got this? Okay? Now we're going to have to learn how to write the equations. There's a few different situations where you have to write the equations. It depends on what they give you. So let me explain to you all of those situations. When given the center, HK, and the radius R, simply plug in the H, the K, and the R values into the standard form of the equation. Literally. Just memorize x minus h squared plus y minus k squared equals r squared. And just plug it in. For example, what is the equation of the circle with center negative 5, 4 and a radius of 3? X minus h, so plus 5 squared, plus y minus k squared equals r, which is 3 squared, which is 9. Done. Done. If you know this formula, it's Mickey Mouse time. Easy peasy. Nice and simple. Example 3, what is the equation of the circle with center 4, negative 3 and radius 6? Okay. X minus h squared plus y minus k, negative times the negative is a positive, squared equals 6 squared, which is 36. That is the equation of a circle. Does that make sense, boys? May I continue? Okay, thank you. When given a polynomial representation of the equation, you must, I hope you can remember this, complete the square for both the x and the y values, and then write it in the proper form. Let me explain what I mean. Don't stress. This is actually a lot easier than what you think if you remember how to complete the square. Remember that when you complete the square, you want to get the squared term and the regular term by itself on the left, right? Same thing here. But you're going to complete two squares here. You're going to have the x. I'm going to leave a space, right, for my b over 2. Plus, you have the y now. I'm going to leave a space for the b over 2 equals 8. So all I did was combine or separate my x's and my y's. I move over my constant if I have to. And now I'm going to complete the square. Please remember that when you complete the square, you are adding b over 2 squared to both sides. So in this case, 8 is b, b over 2 is 4, so plus 4 squared. Whatever I do to this side, though, I must do to that side. Then for my y, my b is negative 10. Negative 10 divided by 2 is negative 5. So I go plus, in parentheses, negative 5 squared, and I add that to the other side as well. Before I continue, I want you to take a deep breath and talk to me. Be honest. We've been on break for a while. I want to make sure that this is clicking. Talk to me, sir. Thank you. When I'm adding the b over 2 squared, yeah? Yes, you're going to have to convert this into 16 and that into 25. But I'm just showing you. I didn't want to skip a step and mess you up. Thank you, sir. Yes, sir. Okay, that is a very dangerous thing. The question was, can I do one equation with x squared, then a separate equation with y squared, and then add things together? No. Yeah, let me rephrase that. You can, son, but you're going to make a mistake more often than not, because you're going to have a total for the x and a total for the y, and how are you going to know how to combine those totals? And say it's going to be a mission. What don't you understand about the way I set it up here? If you want, like, you go like this if you want to show yourself that you're doing two different. No, I'm not getting two separate answers. I have my x that I completed the square for, and my y that I completed the square for. That was the b over 2 squared for the x. That was the b over 2 squared for the y. You with me, my man? No, thank you, sir. Okay, next. Now, remember my trick. Make a perfect square. Square root of that plus the inside of that squared plus square root of y squared plus the inside, so that's minus 5 squared equals 8 plus 16 plus 25. So what, that's 49? Is that right? Boom, done. What is my center here, guys? What's my HK? What's my center? Negative 4, 5. And what's my radius? Talk to me, boys. Talk to me. This is it. This is the hardest part of today. Sir. And then if I ask you to graph it, then you would graph it, yes, sir, 100%. This is the hardest part of today, in my opinion, because you have the completing the square. But if you know how to complete the square, it's pretty Mickey Mouse. Let's try another one. All right. Thank you, guys. Okay, let me give myself a little bit more space here. Wait, why is that? Oh, okay, because that should be there. Okay. That's why. All right. I'll write the following equation in standard form. All right, let's get my x's together. And I'm going to go ahead and add my b over 2 squared here, which is negative 3 squared. You guys with me there? Did you see what I did there? Yeah? So I'm going to add over here that negative 3 squared, which is a 9. You with me? That was my x. I'll do my y in blue. Plus y squared plus 14y plus b over 2 squared is going to be 7 squared, which I add to both sides. Did everyone see that part? And now in green, I'll finish it up. I'll make a perfect square here. That's x minus 3 squared. Remember, square root of the first inside of the b over 2 squared plus y plus 7 squared. Remember, square root of y squared goes there. Inside of the b over 2 squared goes there. And that's going to equal 58, 64? No, 66. I'm wrong. Yeah, because 66. Perfect. Yes, sir.
Isn't the 3 positive and the 7 negative? Because the equation is x minus h plus y minus.
My center is going to be 3, negative 7. Talk to me, kid. Where are you getting confused? Because you just confused me with that. You just said, isn't it x minus 3? Yeah, it is x minus 3. That's why it's there.
No, I mean, the equation x.
This is the equation, Papa. Squared.
No, I mean like the original without numbers x minus h. So since it's negative, wouldn't it become positive? Since it's x minus h, so now.
No, since it is x minus h, what is the value of the h here? No, h is positive 3. Bubble. X minus h. If h is 3, isn't that x minus 3, son? No. Okay. And I really appreciate your question. I really understand it. We're not going to stop this until you understand this today. Mira. This is x minus 3. You're right. Doesn't that come from x minus h? So isn't h 3? If h was negative 3, wouldn't it be x plus 3? Because it's opposite. No, I'm so proud of you. Thank you. You got it for sure? Everyone understand what he was confused on? Because that's a really valid question there. It's a great question. Thank you, brother. Thank you. But now let's just make sure we got this clear. So what is my center here, guys? 3, negative 7. Very good. And what is my radius, my boys? Whatever it is, the square root of 66, right? Which would be like, no, it's 3.2 something. No, it's going to be like 8 point something. It'd be 8.12 or something like that, roughly. Okay? Does that make sense, gentlemen? Okay, one more thing. You ready?
Yeah.
Okay. Because we got plenty of time. Now, 3. Last situation. When given the center and 1 point on the circle, or the endpoints of the diameter, you must use the midpoint and or distance formula in order to find the radius. Once found, plug in the values into the standard form formula. So what's happening here? They say find the standard form of an equation of a circle that is at center, that's center 0, 3, and contains a point 3, 7. All right. Let's go ahead and graph this just so you can see what's going on. Just so you can see what's going on. Okay. So I have my center at 0, 3. So that's 1, 2, 3. It's about right there. And it contains a point 3, 7, which is 1, 2, 3, 1, 2, 4, 5, 6, 7. So I know that the circle's going like that, right? Somewhere like that. Correct? Okay. I know that that's my radius. Correct? I have this here as my 3, 7, and I have this here as my HK, right? So I know my HK is 0, 3, right? All I need is my radius. Yes, sir.
Okay, how do you know that's 37 and 03 that's would be the radius? Because it says it contains,
Exactly. It contains the point 37. If it contains the point 37, that means that on this circle, 37 is contained as a point on the circle. Thank you so much. Great question. Great question. Okay, so how do I find my radius here? Distance formula. Thank you. Distance equals x2 minus x1 squared plus y2 minus y1 squared. So that's going to equal 4 squared is 16 plus 9, square root of 25, r is 5. Are you with me here, guys? Promise? Now, let's write the equation. Now we got it. It's easy. X minus h squared, so the h is 0, plus y minus k squared equals r squared, which is 25. Talk to me, my friends. I'm here. And we got plenty of time. I use the distance formula to find the radius. Thank you. Because isn't the radius the distance from the center to any point on the circle or contained within the circle? Thank you. Continue. Thank you, gentlemen. Okay. Find the standard form of the equation of a circle with endpoints. Oh, he's a little different now. Endpoints of a diameter of -5, -3, and 7, 2. Okay. In this case, let's picture what's going on here. In this particular case, my friends, we have an endpoint of the diameter at -5, -3. 5, 1, 2, 3. So that's -5, -3. That's one endpoint of the diameter. Then I got 7, 2. 1, 2, 3, 4, 5, 6, 7, 1, 2. Okay? That's the diameter of the circle. This is not an accurate circle, but roughly what's happening is something like that, right? That is not accurate. That is just so that my brain can visualize. Oh, okay, this is the diameter. The center, somewhere around here. I don't know. Can I just visualize these things and be accurate? No. Can I visualize it to show myself what's going on? Heck yeah. Okay? So I have these two diameters here. I already know what I'm looking for, so I gotta first find my center. I gotta find the center. And the center of this is the midpoint of the diameter. Okay? So what is the center here? My midpoint is x1 plus x2, so 7 minus 5 divided by 2, comma, y2 plus y1 over 2. So this is, yeah? Yes, I know. I did it correctly. 7 minus 5 is 2. And 2 minus 3 is -1. But thank you, sir. I appreciate that greatly. And then you have -1/2. So that is my center. Guess what? That's my HK. Done. Which is pretty darn accurate. It's right there. Oh, wait. Hold on. Yep, right there. Yeah. So, No, x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. It's the average of the x's and the average of the y's. The x's here, Papa, are 7 and negative 5, and the y's are 2 and negative 3. Thank you, bro. Thank you. Thank you. Sir,
Any x works for like x1, any x works for x2.
you could choose negative 5 as x1 or x2. Yes, sir. Especially since they're a sum commutative property. Okay, so I have my HK. Now, you have two choices for radius. You can find the distance from the center to either endpoint, or find the whole distance of diameter divided by 2. What do you want to do? I don't care. You want to do the whole distance divided by 2, so you want to do double work. Okay, that makes sense, guys. I like that. I'll do it that way if you want, but if I were you guys, I would do the easier way, okay? The distance, guys, if this is my center, wouldn't it be easier to find this distance right here? Wouldn't that be the radius? As opposed to finding the whole distance and then dividing it by 2? Why would you want 2 steps instead of 1 step? Okay, think about it. So let's do it. My x1 and y1 are 1 negative 1 half. Then my x2, y2, I'm going to make it 7, 2. So my distance equals 7 minus 1 squared plus 2 minus a negative half, so plus 1 half squared. And that's going to equal 6 squared, which is 36, plus 2.5 squared, which is 6.25. So that's the square root of 42.25, which is roughly like 6 point something. What is it? Is it 6.5? Guys, are you just guessing, or are you using a calculator for this? Can you use a calculator for me, please? Thank you. 6.5. Perfect. So that's my radius. So what is the formula to this bad boy here? Or the equation? X minus h squared plus y minus k squared equals, and actually, you know what? Actually, why are we making this omission? Isn't r square root of 42.25? Right? Don't we have to square it for the formula? So it's just 42.25. Because what happens when you square a square root? They cancel. Does that make sense, boys? We got plenty of time. So, any questions? Yes, sir. Thank you. Why was I doing what? Yeah, I found the actual value of the radius, which is 6.5. But then don't I have to square it anyways to put it back into the equation? So it would be easier, once I have the radius right here, square that. And what happens when you square a square root? They cancel, and I'm left with 42.25. Does that make sense? Okay. Thank you very much. Hope you learned a lot. Have a great day.